So we will start today by writing our I can statement, which is I can graph and solve absolute value inequalities. Pause the video if you need to write this down, as I will continue to explain our work here. If we are going to graph an absolute value equation, we're going to always need two answers, just like we did with regular absolute value equations. Now, since this is an equality, if it has a less than sign or a less than or equal to sign, then we need to recognize that this is an and problem, meaning that we will have two solutions that should overlap each other. So we're going to see this in example 1 on the next slide, where now I'm going to set up the problem. M plus 2 is less than 11 without our absolute value bars. And then I'm going to solve it first just as our regular answer would. So subtract 2 from both sides, and I'm going to get M is less than 9. Remember, with absolute value bars, we need to solve the problem twice. So I need to set it up again as M plus 2 is then equal to negative 11. Because I'm making this a negative 11, I have to flip the sign. So notice here how I had to flip the sign from the original because this answer became negative. So if I make the answer negative, I need to flip the sign. Then I will solve that like normal, where I do minus 2, so M is greater than negative 13. It asks us to graph our number solution, so I'm going to plot some points here, label them, and then I'm going to graph the first one. M is greater than negative 13. It's an open circle. So let me connect these so you see this is this graph. And then I graph the other one, that M is less than 9. And we see that they are going towards each other, so we need to identify where they overlap, and they're both open circles, so I leave them as open circles. In example 2, we see that it is a negative solution. You cannot start with a negative. We cannot say that something that's being absolute valued is equal to, less than, or equal to, less than, greater than, any of the symbols. It cannot be a negative to start with. They cannot give you a negative. That is a no solution. So we cannot start off as a negative. That's a no solution. So try the two below, and we will go over them on Monday. So next in this problem, we have our word problem that reads, a recent survey showed that 52% of teens ages 14 to 18 believe that students are borrowing too much money for college. The margin of error was within 3.5 percentage points. Find the range of students who believe students are borrowing too much for college. So below here, I copied this from our notes from yesterday. This was right above example 3 that said, when solving problems involving inequalities, the word within is meant to be inclusive. So we're going to use an less than or equal to, or a greater than or equal to. The word between means it is exclusive, so we're going to just use less than or greater than. Now think back to when we did absolute value problems. We did see word problems where we set up that we're going to have the absolute value of x minus a number is, and in this case we're going to do less than or equal to, because we want the difference between the actual percentage of teens and the percentage from the survey, so that's why we chose the less than or equal to sign. Now recall again from when we did absolute values in the last chapter that the number that they give us is going to go inside, so the 52 needs to go inside, and the number that it's going to be within or between will go on the outside, so the 3.5 will go on the outside. And then we solve this like normal. Set them up, and then we're going to add 52 to both sides, and then we end up with x is less than or equal to 55.5. So that is the highest percentage range possible. And now we need to figure out the lowest. Again, when we set this up, we need to say x is minus than 52. Since we are making the answer a negative 3.5, we need to flip our sign again. So flip our sign because we made it negative. And then we continue to solve it like normal. So that x will be greater than or equal to 48.5, and that is all you need to do for that problem. Try the next word problem on your own, and we'll go over it on Monday. In this last example here is when we're going to be working on OR problems. So if you have a greater than sign or a greater than and equal to sign is when we will have OR problems. So we are going to solve the problem below, and we're going to graph it, and when you graph it is when you will see it's an OR problem. If you do not graph it, you will not see that it's an OR problem other than indicating the inequality sign. So 3n plus 6 is greater than or equal to 12. And I'm going to solve that, so subtract 6, divide by 3n. I end up with n is greater than or equal to 2. Then I repeat this with a negative 12, and I need to flip my sign when I do this. So 3n plus 6 is less than or equal to negative 12. Subtract 6, so 3n is less than or equal to negative 18. We don't need to do any flipping of the sign because we're dividing by a positive. So then we get n is less than or equal to negative 6. So now when I graph both of these over here on my number line, you'll see that they are graphed in the opposite direction. So we can see clearly that they are an OR problem. This is the end of the lesson. If you have any questions, please star them, and we will discuss them on Monday. Have a great weekend.